So back to stoichiometry for just a second. Having covered concentration and solutions, we're going to revisit stoichiometry and the stoichiometry map. So you'll remember the center of the stoichiometry map is moles with the mole ratio there in the middle, and there's a bunch of different ways we can get to that central feature. We can go through mass, we can go through volume of a gas at standard temperature and pressure, and we can go through representative particles. But we have also learned, right, that molarity is equal to moles per liter. So if you know the concentration and volume of a solution, you can figure out how many moles of solute, which is kind of the reacting feature in a solution. And so if we have the volume of a solution, we can get ourselves to moles through the concentration. And on the other end, if we know our moles of unknown and we know our volume of solution, then we can figure out the concentration of a product in a solution reaction. So let's take a look at how this works. So how many grams of ammonium nitrate can be produced when 55.0 milliliters of a 3.2 molar ammonium carbonate solution reacts with 100 milliliters of excess aqueous copper 2 nitrate? So first thing you're going to need is in all stoichiometry problems is a balanced chemical equation. So grab your pencil, grab your paper, pause the video, and write an equation out. And here we are with our equation. Ammonium carbonate, copper nitrate, both AQ. Copper carbonate is your precipitate. And then you also have a solution of ammonium nitrate. And in this question, we want to know how many grams of ammonium nitrate are in that solution. So we start with a known and an unknown. We know we have 55 milliliters of a 3.2 molar solution. By the way, we also know we have 100 milliliters of aqueous copper nitrate, but we know that that is in excess, at least the amount of copper nitrate dissolved. So we don't have enough information to get to moles of that reactant. And we don't know how many grams of product we're going to produce. Okay, so check the map. What are you starting with? Well, you're starting with a volume of a solution and a known concentration, which can get us to moles on the mole map. And we're trying to find grams. So let's go ahead and set this up as we set some of our other problems up. We have our balanced chemical equation here again. We're going to get our given pieces of information written under the appropriate reactants. We are going to find our known and our unknown. We're going to identify any molar masses that we need. So anytime we go from mole to gram, so in this case, it'll be ammonium nitrate. So you're going to want to get that molar mass. And then we're going to check the map, and we're going to see that we are going to do a conversion here from concentration to moles to grams. So you can start with your concentration, your volume of your solution. And then we're going to use the concentration. So there's our volume in the top left corner. We're going to then use the concentration to get us to moles of reactant or moles of known. So the concentration is 3.2 moles of ammonium carbonate for every 1 liter of solution. And so you can see that when we set it up this way, the liters are going to cancel out there. Next step is going to be from here, a pretty standard stoichiometric problem. We're going to do mole ratio, and the mole ratio here is 1 to 2. We're going to need that ammonium carbonate on the bottom and the ammonium nitrate on the top. That's going to cancel out moles. And then our last step is to go from moles to gram. We're going to use that molar mass that we calculated at 80.06 grams of ammonium nitrate per mole. We're going to have the 1 mole on the bottom, and there the moles are going to cancel. And the units we have left are grams of ammonium nitrate. And of course, the problem starts with how many grams of ammonium nitrate can be produced. Multiply across the top, divide across the bottom. Make sure you're checking your sig digs and units in your final answer. And if you go ahead and do that, you should end up with 28 grams of ammonium nitrate. Now, bonus question. What's the concentration of ammonium nitrate in this final solution? go ahead and give that some thought. See if you can come up with a calculation and see if you can come up with a prediction. Pause the video while you're doing that. Okay, so how would we go about sorting that out? Well, we know how many grams of ammonium nitrate we have, and we can use the molar mass that we had calculated to figure out how many moles that is. By the way, if you stop the calculation after the second step, you don't do the 80.06 grams, you can just do a quick calculation. 0.0550 times 3.2 times 2 will give you the number of moles of ammonium nitrate. And then the volume of the final solution, well, we mixed 55 milliliters with 100 milliliters. While those volumes won't always be exactly additive, they're going to be pretty darn close, particularly for low concentration solutions. And as long as there's not a tremendous amount of heat absorbed or given off by the reaction. So we add those together, we'd get 0.1550 liters of solution. Your number of moles is 0.352. Notice I took more sig digs than I needed there on the number of moles, but then we're going to divide those out, and we should get 2.3 molar solution of ammonium nitrate. There will also be some copper carbonate precipitate in that reaction container, and there should be a little bit of copper nitrate left over because it's in excess. So there's a bunch of different things going on in that solution, but with respect to the ammonium nitrate, you should be at roughly 2.3 molar. All right, so here's another one for you to try. This is an identifying a limiting reactant problem. And so go ahead and get yourself a balanced chemical equation. See if you can work through which one of these is going to be the limiting reagent. Come up with a prediction with an answer there. And then pause the video while you work that out. All right, so let's go ahead and work through this together if you've taken some time to do it. We need a balanced chemical equation first. So there we have 2 moles of silver nitrate, 1 mole of magnesium chloride is going to produce 2 moles of silver chloride, and 1 mole of magnesium nitrate. The silver chloride is going to be the precipitate in this double replacement reaction. We're going to put our given pieces of information on our chemical equation there. And then since we're doing stoichiometry, we need to get to moles. So we have 2 different concentrations here. So we want to convert both of those concentrations to moles. So for the first one there, we'll just set up that molarity equation. Solve for N, and in solving for N, we should get somewhere in the neighborhood of 0.15 moles of silver nitrate. On the other reactant, set up the same molarity equation, solve for N, and you're at 0.0875 moles of silver chloride. So now that we have moles of both reactants, now we're just a straight stoichiometry problem. And you remember when you're only asked to find the limiting reactant, you can go from one reactant to the other, and it doesn't matter which one you start with. So I'm going to go ahead and set up my game board, and I'm going to start with the 0.150 moles of silver nitrate. My mole ratio there is 1 to 2. I need the silver nitrate on the bottom. Moles of silver nitrate then is going to cancel out. And then you're going to multiply across the top, divide across the bottom. And when you do that, you get 0.0750 moles of magnesium chloride. And so you have to ask yourself the question, do I have enough magnesium chloride? And it turns out you have more than enough. You only need 0.075, you have 0.0875. So that means magnesium chloride is in excess, and silver nitrate is our limiting reagent. If we had started with the magnesium chloride, we would have expected that number to come out more than 0.150, which would tell us that we won't have enough silver nitrate. So it doesn't matter which reactant you start with, you're going to end up identifying silver nitrate as the limiting reagent in either situation. And so there is a quick overview of using solutions in stoichiometric problems. And so now you have a new skill.